Good afternoon, students. One more video based on Big M method. When we will use Big M method means when we are having the constraints based on greater than or equal to type. Here, one is of less than or equal to and one is of greater than or equal to. See, in simplex method, when we are having greater than or equal to type or equality type, we are going to use either big M method or two-phase method. See, this is a problem based on maximization objective function. The standard LPP form here is taking the coefficients for artificial variables as minus m in the maximization problem. Here, while using what is meant by an artificial variable is the variable where we are having the greater than or equal to type of constraints. Here, greater than or equal to type constraints will be converted to equality constraints by subtracting one surplus variable and adding one artificial variable. See, here we have two constraints. The first constraint is of 3x1 plus 4x2 less than or equal to 6, and the second one is x1 plus 3x2 greater than or equal to 2. So this is the constraint. By seeing that, we can use this either big M method or two-phase method. So the first constraint will be converted to equality constraint by adding one slack variable. And what is the second constraint? The second constraint is x1 plus 3x2 is greater than or equal to 2. That means here we are going to subtract one surplus variable and adding one artificial variable. So x1 plus 3x2 minus s2 plus a1 is equal to 2. So whatever the variables are there, all must be, we are going to take it as a non-negative restriction, that is greater than or equal to 0. So here, what is the initial basic feasible solution? Whatever the decision variables are there in the question, that you are going to take it as 0. Then we are going to get the basic variable values. That is s1 is equals to 6 and a1 is equal to 2. Here in the big M method, when it is of maximization problem, we are going to take the coefficients for a1, that is the artificial variables introduced. For them, we are going to take it as minus m in the objective function. And whatever the slack variables and surplus variables, we have to take it as coefficients as zeros only, except for the artificial variables. Now, here the value of maximum z is nothing but minus 2m. And what is the initial simplex table? Proforma will not be changed. Well, the proforma is CB, basic variables XB, X1, X2, S1, S2 and A1. Why? Because we have been introduced S1, S2 and A1. Here, what are the values here you are going to have? S1 and A1, where S1 is equal to 6 and A1 is equal to 2. These are the basic variables right now. S1 is 6 and A1 is 2. Now, what is meant by CB? Coefficient of the basic variables. The coefficient of basic variables for S1 is 0, for A1 is minus m, that you are going to write here. Now, these the values which you are going to take from the constraints itself, and whatever the values are there in the basic variables, those must be following identity matrix. If there are 2 variables, it is going to follow I2. If there are 3, it is going to follow I3. Now, in the same way, again you have to find out the value of z. The formula of z is summation CB XB. CB is nothing but these values. XB is nothing but these values. 6 into 0 plus 2 into minus m. What you will get? Minus 2m. That means you will not be getting the zj values for the first row. For the second one, 1 into minus m, you are going to get minus m. 3 into minus m, that is minus 3m. 0 into minus m, 0, minus 1 into minus m, that is plus m, 1 into minus m, that is minus m. So this is the values of zj. What is the value of zj minus cj? Zj minus cj, minus m, minus 1. Here minus 3m, minus 5. Here 0, minus 0, 0. M minus 0, plus m. Minus m, minus of minus m, that means plus m. Sorry, 0. Now, what is the most negative value? How we are going to find out most negative value? See, m is nothing but the largest penalty which we are going to give in the big M method. What is the largest penalty here you are going to give? When it is a maximization of objective function, or we are going to take the value of m as positive. That means if m is taking it as 10, or m you can take it as 10 or 15 or anything. Largest penalty means what? You can take it as a 100 or 200 or 300, like that you can take anything. So we are going to give the m as the biggest penalty. So here if you are substituting the value of m as 100, you are going to get minus 305. So this is your most negative value. Yes or no? So this is your incoming variable. After finding out incoming variable, we have to find out the outgoing variable. How we are going to find out the outgoing variable? The outgoing variable is nothing but minimum ratio formula, xb by x2. Why x2? This is the incoming variable, that's why xb by x2. So 6 by 4, 1.5. 2 by 3, 0.67. Out of these two, what is the minimum value? 0.67. So this is your outgoing variable. See, here you have to remember one point, that if it is of the outgoing variable is of any artificial variable, just drop off that variable completely in the next simplex table. That means there is no need to write that value of a1. That's why I put cross mark here. So a1 is the outgoing variable. So a1 values you are going to drop off. Now, what is the incoming variable? x2. And what is the outgoing variable? a1. In the place of a1, we are going to write x2. So what will be the coefficient of basic variable? 5. In the next simplex table, we are going to see that. See here, this is the next simplex table. CB, basic variables xb, x1, x2, s1 and s2. Cj is also common. While you are dropping off the value of a1, you will not be getting here. So 0, s1 coefficient is 0 and x2 is the incoming variable in the place of artificial variable a1. So a1 coefficient is, x2 coefficient is 5. So now we are going to do the row operations. What is the row operations? How we are going to do the row operations? By taking the last table values, that is 3. Here both the intersection of incoming variable and outgoing variable is the key element. So this is the value of 3, which you are going to make it as a key element, that is 1. And whatever the values are there in that key column, this is the key column now. So this value you have to make it as 0. For that sake, I am going to use the row operations. That is, the first one is R2 dash is replaced by R2 by 3. So here, this is nothing but your new row R2 dash. R2 dash. R2 dash is, or the second row completely you are going to divide by 3. What is the old row? You are having here 2. So 2 by 3, 1 by 3. Here 3 is there. So 3 by 3, that is nothing but 1, 0 by 3, that is nothing but 0. Here it is minus 1, so minus 1 by 3. So this is your new row. You have to use this new row to make this value as 0. Okay, so I have been written that row operation here. Instead of getting this new row of r1 dash, we are going to use this row operation, that is r1 dash is replaced by r1 minus 4 into r2 dash. Why? Because in the place of r1 you are going to have 4. So if you are multiplying the value of r2 dash, in the place of r2 dash you have 1. Then you are going to subtract these two, you are going to get 0. So I have been written r1 and r2 dash, which is multiplied with 4, that is this row, and you are going to get the value of r1 dash. Whatever the values you have got here in the r1 dash, we are going to substitute over here. That is 10 by 3, 5 by 3, 0, 1 and 4 by 3. See, what are the basic variables s1 and x2? See, s1 is 1, 0 and x2 is 0, 1. It is should follow a I2 matrix, that is nothing but identity matrix with 2 by 2 values. Now, again you have to find out the value of z. Z is nothing but summation cbxb. You got as 10 by 3. That means 2 into 5 by 3. That is 10 by 3. Zj. 1 by 3 into 5. 5 by 3. 1 into 5, 5. 0. And minus 1 by 3 into 5. Minus 5 by 3. So, Zj minus Cj is 5 by 3 minus 1. 2 by 3. 5 minus 5, 0. 0 minus 0, 0. Minus 5 by 3. Minus 0, you are going to get minus 5 by 3. So, this is not an optimum solution. Why? Because again you got a negative value over here. So, this will be continuing where this is the incoming variable. What is the formula for minimum ratio? Minimum ratio is nothing but xb by incoming variable. xb by incoming variable. So, xb by incoming variable. So, 10 by 3 by 4 by 3. You are going to get 5 by 2. And what is the next one? 2 by 3 by minus 1 by 3. I already told you that no negative values and 0 values will be considered in the minimum ratio. So, just make it as a dash. So, this is your outgoing variable, where S1 is the outgoing variable. And what is the incoming variable? S2. That is in a new table we are going to write that. CB, basic variables XB, X1, X2, S1 and S2. For that, we are going to have S1 is outgoing and S2 is incoming. S2 coefficient is 0 and X2 coefficient is 5. So, we are going to form a new row values, that is R1 double dash and R2 double dash. What is the key element here? The key element is 4 by 3. To make it as 1, we are going to multiply the first row completely with 3 by 4. After doing that, I got these values, that is 5 by 2, 5 by 4, 0, 3 by 4 and 1. And what is the values in the key column other than key element? We have to make it as 0. So this is the value of minus 1 by 3, you have to make it as 0. Then what is the row operation you are going to use? So the row operation here you are going to use is R2 double dash is replaced by R2 dash plus 1 by 3 into R1 double dash. Why? Because here you have minus 1 by 3. If you are adding with plus 1 by 3, you are going to get the value of 0. That's why we are going to do that. The row operation here, we are going to use that. So here it is 2 by 3, 1 by 3, 1, 0, minus 1 by 3, that is R2 dash. If you are multiplying with 1 by 3 into R1 double dash, you have to use the new row, which is the key row. Okay. So here R2 double dash, you got this value, that is 3 by 2, 3 by 4, 1, 1 by 4 and 0. we have been added these two rows. That is minus 1 by 3 plus 1 by 3. We got 0 here. That is the same row which I have been noted here in the R2 double dash. Again, you have to check the value of z, where z is equals to formula summation CBXB. Summation CBXB means 5 by 2 into 0 plus 5 by 3. Sorry, 5 into 3 by 2. You have got 15 by 2. ZJ, and you are going to get all the values of ZJ as positive only, and ZJ minus CJ is also positive. So whatever we have been did, that is correct. And you can check that the values of basic variables s2 and x2 in the second simplex table must follow identity matrix. S2 is 1 0 and x2 is 0 1. So you did correct. Now all the zj minus cj have been or positive, that is greater than or equal to 0. Therefore the solution is optimum. And maximum z you got, it is 15 by 2, where the decision variables x1 is not there in the final simplex table, which is of 0, and x2 is nothing but 3 by 2. And we can check that in the objective function, where the objective function you are going to have x1 plus 5x2, where x1 is 0 and x2 is nothing but 3 by 2. Just we are substituting that, you got maximum z is equal to 15 by 2. While in the solution you got maximum z equal to 15 by 2. Here also you got 15 by 2. With that, the maximum objective function is done and the begin method maximization case completed.